Hello, good morning. Today I want to explain the analysis of isoconal test, isoconal test, which are the most important tests in gas well. I will not go in detail in explaining the MIT or modified isoconal test, but I will show what is this. First of all, I have fluid here. I have shut in well, Q1, PW flowing 1. So I have a Q, PWS1, PW flowing 1. Shut the well. This is a buildup. I can analyze this buildup, or this buildup, or this buildup to find the permeability, skin, whatever. In modified isoconal test, the flow period equal to shut-in period, not like isoconal test. So this modified by cuts. How to analyze this? So the main target is to find the absolute open flow potential. Absolute open flow potential. What does it mean? When the bottom hole flowing pressure reduced to atmosphere 14.7, how much the well will produce. That's the definition of absolute open flow potential. I have two methods. I have empirical method. I have empirical method here. Empirical method, Q standard, C, PW, N. Okay, is empirical, has no derivation. I have a Q, I have P, and I have PW flowing from the isoconal test. So I plot this on the x-axis and the y-axis, and this is on the x-axis to get N and C. So when I get N and C, I can plot the deliverability test of this well. When I assume PW flowing, calculate Q, PW, calculate Q. And I can calculate the absolute open flow potential when I set this to 14.7. I know this, so I calculate the open flow potential. So the main target, find C, find N, and then absolute. This is what called empirical, has no derivation. I prefer to use this is, look, PW flowing. This is the analysis, stabilized, deliverability test, plot, semi-flow analysis, whatever it is. I prefer to use this. They call it theoretical. The same thing, really, the same thing. AQ square pressure square drop in case of pressure due to laminar flow and pressure drop due to interstitial turbulent flow. Equation 3 applied for values Q star as shown. Always in gas well, we prefer to use pseudo pressure. Psi. Some books they call M of P. Some books M of P, and some book they call it Psi, because this is no limit on the pressure used. Okay, by al-Husseini. I am not teaching isoconal test or that. This need gas well testing. But I'm just showing you how to use these things. BQ square, pseudo pressure due to terms, whatever it is, and the deliverable potential, and the main target is to find A and B, and then calculate the Q. And delta C, I can cut open the flow potential too. I will show it to you. This is the isochronal, modified isochronal test. Shut in period equal to flow in period. So you have to take this subject in gas well testing, a lot of testing gas well. Plot of delta P square in term of delta P square or in term of psi. I prefer to use psi. Okay? Now, this is the general idea about gas well testing. The most important test I use a lot in a company. I use them a lot in a company. So the target today is to calculate the absolute open flow potential using empirical and using theoretical. I prefer to use this theoretical one, okay? Absolute open flow potential. Why I am using this program? Because I am not using the graph, just go to graph. Where's the graph? Where's the graph? I will show you the graph. Where is that now? MOP, viscosity, MIT, this is the definition. Okay. Because I am not use eye judgment. See the graph, absolute open flow potential, open flow potential. This is a stabilized point. I will show it to you. Here, first of all, clear everything before. I need the gas gravity, how much? Because I will use MOP and the gas temperature. And I have 4 points, as I told you here. Where is that? MIT. I have 4 points here. It's 1 point, 2 point, 3 point, 4 point, and stabilized point. 4 point. 1 point, PWS Q, Q2 PWS W2, Q3, Q4, and stabilized. Okay, I have this. I have this input data, and this input data only. That's all. Okay, don't play with it. Sometimes we have 3. So clear before 1. Okay, and then just execute. Good. So I calculate M of P, whatever is absolute open flow potential for empirical. And this is for theoretical. Okay, now I can, from this data of A or FT, whatever is, and A of empirical, I can calculate the empirical, the derivative curve. The derivative curve. This is empirical. I explain it to you, and theoretical, and this is viscosity. By the way, I calculate the viscosity, MOP, and then graph, whatever. This is the graph. Okay. I can use in terms of P square. This is MOP, this is AOF. This is MOP, or psi of P. Psi of P. I use psi of P empirical and psi of P theoretical. I can use, I can use in terms of P square. In terms of P square. Here, in terms of P square, click. I have this point here, input data. I don't need because the gravity or the temperature, and then just run. Look, this is the theoretical, another example, theoretical and, I'm sorry, empirical and theoretical. I can see this open the floor. This is the graph, okay. What you can really see the graph of, this is the graph. You can draw the deliverability curve. See? Oh, I can use this, really. I can use this sometimes when I'm so, I use this. How many transient point? 4 point. 1, 2, 3, 4. Put 4. Okay. Let me see here. How many point do we have? 3.45. Copy. Let me see. Probably I can do it. Anyhow, you can do it by yourself. Put here data. Here 4 point. 4. I have 4 point. I can. How many this? Let me. I can put some data and just calculate. Give you empirical, AOF, and this correlation coefficient, and CS, and theoretical, and that's all. Okay? That's all. Anyhow, this will, if you need the Excel sheet, I can send it to you by email. You will use it a lot in the field if you are really, if you are